Welcome to Unit 3. In this unit, we'll be exploring situations with multiple graphs. The point where these various lines or points of intersection will be referred to as the solution of these two or more lines. In this example, we are showing the graph of two equations. The solution to these two lines, or as they are referred to here, linear systems of equations, is 2, 2. It's simply the point at which they cross. Here in this example, the graphs of the two lines intersect at a particular point, in this case 5, -4. We would say the solution to these two equations is 5, -4. Here in this example, the graph of the two equations intersect at the point -3, 5. We're not told in any of these examples what the equations are, but we can see visually by looking at the graph that they intersect at a specific point. In this example, we are given two equations and asked to graph the lines. The Boy Scouts are traveling along a path indicated by the equation y = -x - 3. And the Girl Scouts are traveling in a direction that's represented by the equation y = 2x + 3. Once these two lines are graphed, we can see that they intersect at the point -2, -1. So far, we have relied on detecting the point of intersection by looking at the graphs visually. If we have the equation for the two lines, we have other options available to us for finding the point of intersection. We could create a table of values for the two equations and take note of where the coordinate pair is the same. In this example, we can look at the table of values and see that the coordinate pair -2, -1 is the same. This tells us that there is a point of intersection at that point. Let's revisit the example using the Scouts to review our left side and right side checks. We established the point of intersection was -2, -1. Now, we'll take those two values and we'll substitute them back into the two equations and check for equality. As you can see, when this is done, we end up having a situation where the left side equals the right side. For y = 2x + 3, substituting those values -2, -1 in shows us an end result of -1 equaling -1. And the same on the right side for the equation y = -x, -1. There are several ways to find the solution to a linear system. So far, we've just been using graphing, but there are also substitution and elimination methods for finding the solution or intersection for any two graphs. Here's another example using graphing. We are given two equations, x + y = 6, and 2x - y = 0. We'll begin with the equation x + y = 6 and rewrite it in a slope y-intercept form. This readily tells us that the slope is -1 and the y-intercept is 6. Looking at the other equation, again, We'll rewrite this so that it's in slope y-intercept form, ending up with an equation y equals 2x plus 0, telling us that the slope is 2 and the y-intercept is b. We now have enough information to graph the two equations, and when we do, we see that they intersect at the point 2, 4. So we can say that our point of intersection is 2, 4, or our solution is 2, 4. We can check this point of intersection by substituting the values for both of these, and once again, when we check the left side and the right side, we see that in both cases they equal one another, giving us some comfort in knowing that we have the correct solution. In this example, we are given two equations, y equals x plus 3 and 3x plus y plus 1 equals 0. Beginning with the equation y equals x plus 3, we can state immediately that the slope is 1 and the y-intercept is 3. With the equation 3x plus y plus 1 equals 0, we'll need to rewrite that so that we're in slope y-intercept form, giving us a slope of negative 3 and a y-intercept of negative 1. We have enough information now to graph it, where we can visually see that the point of intersection is negative 1 and 2. Once again, plugging these values into our two equations and establishing that our left side equals the right side in both cases. Our last example, two equations, 2y minus 3x equals 12 and negative x plus 4y equals 4. Rewriting our first equation so that it's in slope y-intercept form gives us an equation y equals 3 halves x plus 6, telling us that the slope is 3 halves and the y-intercept is 6. With our other equation, again, rewriting this in slope y-intercept form, we end up with an equation y equals 1/4 x plus 1, telling us that our slope is 1/4 and our y-intercept is 1. Graphing this information, and we can visually see that our point of intersection is negative 4, 0. And lastly, doing our right side, left side check. Once again, establishing that the left side equals the right side in both cases, telling us that our point negative 4, 0 is valid.